Alright, problem number 1, part A. Tell whether the graph of the function opens up or down. Because the number in front of the x squared term is positive, so 1, this thing opens up. So its basic shape looks like this. Its vertex is right at the bottom here, so it's going to make its vertex a minimum value. So the y-coordinate of the vertex that you see right there, that's the smallest y-coordinate that you're going to encounter if you look at all of the points along this parabola. And that's what we mean by a minimum value. So it's not that its x value is the smallest, it's the y-coordinate of the vertex is the smallest that you will encounter when you look at all of the points along the parabola. Part C says find an equation for the line of symmetry for the graph. So line of symmetry is going to be x equals the opposite of b divided by 2a. In this case, b is 6, or b is negative 6, so the opposite of negative 6 is 6. So we have 6 divided by 2a, which is 3. So the line of symmetry is going to be at x equals 3. So that's that vertical line that runs through the vertex. Part D, we're looking for the coordinates of the vertex. So vertex, well, we already found the x-coordinate of the vertex. That's negative b over 2a. So that's 3. The y-coordinate is going to be whatever y is when x is 3. So 3 squared minus 6 times 3 plus 1. So 9 minus 18 plus 1, which is negative 8. Part E, the y-intercept. Well, the y-intercept is where your curve or your function crosses the y-axis. So along the y-axis, the value of the x-coordinate is 0. So when x is 0, what is y? Y is 1. The point symmetric to the y-intercept the x value of that point is going to be double the x-coordinate on your vertex. So the x-coordinate on your vertex is 3. So this will be 6. The y-coordinate is going to be whatever the y-coordinate of your y-intercept is. So 1. So if you want to look at why that is the case, our vertex is at the point 3, negative 8. Our y-intercept is at 0, 1. So if you sketch the left-hand side of your parabola here, it's obviously going to continue up. Here is your line of symmetry. Your y-intercept is here in purple. If we reflect that across the line of symmetry, notice that this distance that I have right here, that distance is the x-coordinate on the vertex. So to go all the way across, so to span not just this distance but all the way across, that's double the length of that highlighted yellow segment. That's double the x-coordinate on your vertex. And the height of the symmetric point that you're looking at right here, the height of that point is the same as your y-intercept. Alright, question 2. This parabola opens down, and that's because of the negative 2 right here. Negative value in front of x squared says this opens down. So parabola that opens down, its vertex is going to be a maximum. part C asks us about the line of symmetry. That's negative b over 2a. Well, in this problem, what's b? Well, if you're not sure, it might help to rewrite this as negative 2x squared plus, well, I don't have any x's, so 0x plus 6. So b is 0, a is negative 2. 0 divided by negative 4 is 0. Part D, coordinates of the vertex. Well, the x coordinate is negative b over 2a, so that was 0. And the y coordinate is going to be whatever the value of your function is when x is 0. So if you notice, this is a little different than the last one because the vertex is actually going to end up being the same point as the y-intercept. So for part E, the y-intercept, well, when x is 0, what is y? Well, y is 6. That's going to make a little bit of a difference when we look at the symmetric point. So think about your graph here. You're at over 0, up 6. This thing opens down. So let's say this is your basic shape here. Well, if the vertex is also the y-intercept, and you reflect this point across the line of symmetry, where's it going to go? Well, it's going to stay exactly where it's at. So it will be 0, 6. Alright, question 3. I already know the vertex is going to be at 4, 3. The quadratic that you're looking at is given in vertex form. But if you haven't noticed what the pattern is yet, I'm going to help you convert this to standard form. And then we'll go with negative b over 2a for x and plug it in to find y. So we're going to expand this out. X minus 4, x minus 4. So x minus 4 squared, you know, is x squared minus 8x plus 16, because that's a minus 4 times a minus 4. We will now distribute 2 through. 2x squared minus 16x plus 32 plus 3. Combine like terms. 2x squared minus 16x plus 35. Alright, now you're looking at standard form. So the vertex, negative b over 2a, which is 16 over 2 times 2, which is 4. So you can plug 4 into one of two equations, either one that you see here in yellow, the second or the first. Realize these two equations, these two quadratics, they're the same quadratic, same parabola. Their equations just look different. So plug 4 into either one of those and see what you get for y. I'm going to plug 4 into the first one, because notice 4 minus 4 in the parentheses gives me 0. If I square 0, so that thing turns out to be 0. Square 0, you get 0. Multiply by 2, you get 0. And 0 plus 3 is going to be 3. We're also asked for the y-intercept and the point symmetric. Y-intercept, that says plug 0 into x. Once again, use either equation and see what y is. I'm going to go ahead and use the second one. That's helpful for the y-intercept. So when x is 0, y is 35. The symmetric point to the y-intercept, double the x coordinate on the vertex. So 4 doubles to 8, and we have 35. Okay, question 4, same set of instructions. If you know what the pattern is, you know the vertex is going to be at negative 6, negative 1. If you don't know what the pattern is, you're just going to expand this out and put it in standard form. what happens when you square x plus 6? Well, you get x squared plus 12x plus 36. Distribute the 1/3 through. You get y equals 1/3 x squared plus, well, what's 1/3 of 12x? That's 4x. What's 1/3 of 36? That's 12. Combine like terms. 1/3 x squared plus 4x plus 11. Alright, so now we're working with standard form. You know, if you want to find the vertex, that x coordinate is negative b over 2a. Well, we have our b value is 4, so negative 4 divided by 2 times a, and a is 1/3. Let's create a little more room down here. So we have negative 4 divided by, well, 2 times 1/3 is 2/3. And we all know that when you divide by a fraction, you take whatever you have in the numerator and you're going to multiply it by the reciprocal of the denominator. So if you have 2/3, you multiply by 3/2. And negative 4 times 3/2 is negative 12/2, which is negative 6, which in the beginning we knew was going to be negative 6. Alright, plug that in to find the y coordinate. Well, you can plug it in one of two places. You can go into the original, which is in vertex form, or into the equation that you have down here, which is the same parabola in standard form. I'm going to go ahead and go into the original, because when x is negative 6, inside the parentheses I get 0. Square it, you get 0. Multiply by 1/3, you get 0. And 0 minus 1 is negative 1. Alright, number 5, it says solve by taking the square root of both sides. Not going to be the first thing you want to do, but at some point in the process you need to take the square root of both sides. I'm going to start by adding 7. 4x squared equals 28. Before I take the square root, I'm going to get x squared by itself, so I'll divide both sides by 4. And I have x squared equals 28 divided by 4, which is 7. Now I can take the square root of both sides. So x equals plus or minus the square root of 7. I want to show you something interesting here. If when you had this, if you would have taken the square root of both sides, on the right hand side you would have had the square root of 28. On the left hand side, what multiplied by itself is 4x squared. Well, 2x times 2x is 4x squared. So we have 2x equals the square root of 28. Square root of 28 can be broken down in square root 4, square root 7. So that's 2 square root 7. So if you have 2x equals 2 square root 7, divide both sides by 2. You get x equals the square root of 7, and it should be plus or minus the square root of 28 here. That would have been plus or minus, plus or minus, plus or minus, plus or minus. Either way would work. I would go with the method that we worked down the left hand side to get right here. Number 6, subtract 1, 16 on the right, x minus 3 squared on the left. Go ahead now, take the square root of both sides. X minus 3 plus or minus 4. X equals plus or minus 4 plus 3. Okay. So x is equal to 4 plus 3, which is 7, or negative 4 plus 3, which is negative 1. Now, hold the phone here. You got to go back to 5 and 6. And you say, hey, at any point in time, did we ever square both sides of the equation? Because remember, if you do, you're going to have to go back and check and see if there are any extraneous solutions. And the answer is No, we actually never squared both sides of the equation. We took the square root of both sides, but that's not going to introduce any extraneous solutions. So we are done with 5, done with problem 6, assuming I didn't make any simple mistakes. And now we're on to number 7. Alright, I'm going to go ahead and subtract 6, divided by -2, then square root. So minus 6 from both sides, minus 24 on the right. Divide both sides by a -2. I got x plus 1 squared equals 12. Now take the square root of both sides. The left side is x plus 1. The right side is plus or minus the square root of 12. Subtract 1 from both sides. X equals plus or minus the square root of 12 minus 1. But you can more conveniently write this as x equals plus or minus, well, I think square root 12 can be reduced. The largest perfect square that goes into 12 is 4. So the square root of 12 is square root 4 times square root 3, which is 2 square root 3. So x equals plus or minus 2 radical 3 minus 1. Okay, 8, 9, and 10 quadratic formula. So you want to make sure that your quadratic is in standard form. Ax squared plus bx plus c, and then we want that equal to 0. So that's a nice start for number 8. Remember, the quadratic formula is going to tell you where your quadratic is equal to 0. So it's going to be x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. One thing you're going to have to watch out for is if you multiply 4 times a times c and get a negative value, well, notice you're going to be subtracting a negative value, so you'll have to go ahead and change that to addition. Just something to watch out for. So in number 8, we have x equals negative 7 plus or minus the square root of 7 squared minus 4 times 3 times 1, all divided by 2 times 3, which is 6 on the bottom. So x is equal to negative 7 plus or minus the square root of 49 minus 12 is 37. That's not going to reduce, and that's all divided by 6. So, oops, there you go. There's the answer to number 8. Moving on to 9, we first need to get that quadratic equal to 0. So I'm going to go ahead and move everything from left to right just to keep my x squared term positive. You don't have to do it. There's nothing wrong with this if a is a negative number. So let's add. Alright, so I made a decision to add 3x squared and subtract 2x from both sides. So my left side is 0 and the right side is 3x squared minus 2x minus 11. So x is equal to negative b, so 2 plus or minus the square root of b squared minus 4ac. There's where you got two negatives stacked up in there and divided by 2a. So that's equal to 2 plus or minus the square root of, and I'll go slow here, negative 2 squared is 4, and you're going to subtract 4 times 3 times negative 11. So 3 times negative 11 is negative 33. Negative 33 times 4 is negative 132. So look, you're subtracting a negative, so keep track of that. So this will change to plus a positive. So underneath the radical, we have 136. That's all divided by 6. Square root of 136 reduces. I think the largest perfect square that goes into it is 9. And it goes in, I believe, 34 times. Not 34 times. Well, it's not 9. Alright, 136. Okay, 4 goes in there. 34 times. So square root 136 is 2 square root 34. So x is equal to 2 plus or minus 2 square root 34, all divided by 6. You're not done though. You can factor a 2 out of the numerator. So 2 times 1 plus or minus square root 34, all divided by 6. But if you don't mind, I'm going to write 6 as 2 times 3. And you'll notice that 2 up top, 2 down below cancel. This is getting messy, but your answer is right here. X equals 1 plus or minus the square root of 34 divided by 3. Okay, number 10. Let's move the 3x over. So 6x squared minus 3x minus 7 equals 0. So x equals 3 plus or minus the square root of negative 3 squared minus 4 times 6 times negative 7. Careful there, you're going to subtract a negative. And that's also divided by 2a. So 3 plus or minus the square root of 9 subtract negative 168. And that's divided by 12. So let's move this around. Let's do some more simplification. 3 plus or minus the square root of 177 divided by 12. Does 177 reduce? Is 177 a prime number? No, it's not. 3 goes into 177 59 times, but 3 isn't a perfect square, and 59 isn't a perfect square. I don't believe that 177 reduces. If you remember the trick with divisible by 3, if you add the digits up and that's divisible by 3, it will be. So if you have like 7 plus 7 is 14 plus 1 is 15, and 15 is divisible by 3. I think that's how the trick goes. So we have got our final answer. And that looks messy. So x is equal to 3 plus or minus the square root of 177, all divided by 12. Alright, moving on to problem 11. Find the discriminant, use it to determine how many solutions, and solve it if it has at least one real number solution using the method of your choice. So, in number 11, the discriminant. That's equal to b squared minus 4ac. Now, if you remember, we got some rules here. Okay, if b squared minus 4ac is equal to 0, we have one solution. We have one root, or we have one 0. So this quadratic will cross the x-axis once, And if it crosses only once, it can't really pass through. What happens is the vertex is going to be on the x-axis. If b squared minus 4ac is greater than 0, we will have two roots or two solutions. If b squared minus 4ac is less than 0, that means what you're going to take the square root of is negative. No solutions, because you can't take the square root of a negative number. So, let's look at this. B squared minus 4ac. Well, b is 1. So 1 squared minus 4 times 3 times 2. That's equal to 1 minus 4 times 3 is 12 times 2 is 24. So negative 23. No solutions. Okay, number 12, same set of rules. Find the discriminant. B squared minus 4ac is equal to 2 squared minus 4 times 1 times negative 8, which is equal to 4 minus negative 32, which is equal to 36. Hey, it's positive. We have two solutions. Now, we don't know what our solutions are yet, but we do know that there are two solutions. First thing I'm going to try to do is factor this thing. X squared minus x squared plus 2x minus 8 can be factored to, let's see, what multiplies to negative 8 and adds to 2? That would be plus 4x minus 2. So solutions are x equals negative 4 and x equals 2. Okay. 13. Look at the discriminant. B squared minus 4ac. So, negative 6 squared minus 4 times 3 times 3. Negative 6 squared. Please don't tell me it's negative 36. It's positive 36. Subtract 4 times 3 is 12 times 3 is 36. So your discriminant is 0. You will have one solution. Maybe this thing is factorable. I'm going to go ahead and try to factor it real quick. Before you factor, one thing you're always going to want to check is, do you have any common factors that you could take out? So you want to look at the number in front of x squared, the number in front of x, and your constant. Is there anything that divides evenly into them? Answer is yes. 3 goes into all of those. So let's factor 3 out, and we're left with x squared minus 2x plus 1 is equal to 0. Okay, we're looking for what multiplies to 1 and adds to negative 2. So x minus 1, x minus 1. If you want to think about the Tic-Tac-Toe method with this, not really necessary, but a is 1, c is 1, 1 times 1 is 1. Factors of 1 that add to negative 2 are negative 1 and negative 1. And there you go. So solutions, or solution, is x equals 1. Notice the value of 1 is what makes this set of parentheses 0 and also this set 0. Alright, 14, simplification. I'm going to show you that this is a fraction. So you think about there is a top and there is a bottom. The only negative exponents I see are attached to the x, so that thing is going to move down below and its exponent will become positive. So up top stays 3y squared, down below moves x cubed. 15. Well, I'm going to take care of this negative exponent first. So you have a fraction to a negative exponent. What you're going to do is you're going to flip-flop top for bottom in that entire fraction. Okay? So this negative 2 will become positive 2. And all I want you to do is take top for bottom and just switch them. So 5z negative 2, 12x squared y negative 3. Alright, great. You have one less negative exponent. Now all you have to do is look on the inside and say, hey, that's a negative exponent. It needs to be positive. So I'm going to move that down below. So that's z squared. Find me the other. That's a negative. It's down below. It now needs to live up top for it to be positive. The things we don't move are the 5, the 12, and the x squared. 16. Hey, one thing to remember, anything to the 0 power except 0 is 1. So we kind of have to make an assumption here that neither x nor y is 0. But we'll go ahead and do that. So both of those things are 1. This 3 to the negative 2, that's going to go down below. And that's going to become 3 squared. This 2 to the negative 3 is going to move up top. And that's going to become 2 to the positive 3. Z squared still lives up top. Z to the negative 3 needs to move up top and become z cubed. Well, if you have z times z times z times z times z, how many z's do you have? You have 5 of them. And you have 2 cubed, which is 8, and 3 squared on the bottom, which is 9. And that's 16. We're going to go ahead and skip the problems 17 through 22. We're going to jump right to 23. So, the next thing we want to look at is n plus 7 times n minus 4. So this is really 23 in your packet. This is really 24. Alright. Remember what we've got going on here. You need to take n and multiply by everything in the right set of parentheses. So by the n and by the minus 4. And then you need to go ahead and you need to take 7 and multiply it by everything over here. So the n and the minus 4. 4 multiplications. Let's look at what happens. So first outside, inside, last, if you want that. So n times n is n squared. N times minus 4 is minus 4n. 7 times n is plus 7n. 7 times negative 4 is negative 28. Combine these like terms, and you have n squared plus 3n minus 28. Next set. First, negative 4x times negative 2x is going to be a positive 8x squared. Outside, negative 4x times negative 3 is going to be positive 12x. Inside, that'll be negative 10x. And last, 5 times negative 3 is negative 15. Like terms, 12x negative 10x is 2x. And you have an 8x squared. Let's change these numbers. 25, 26, 27. All we're doing is factoring. Okay. You don't need that tic-tac-toe method here. If you like to use it, I'll show you it here. But it's not really necessary because this number is a 1. But I'll show you anyways. So A, C, A times C is 32. The factors of 32 that add to 12 are 8 times 4. 32 and 8, greatest common factor is 8. 1 and 4 is 1. 1 and 8 is 1. 4 and 32 is 4. So we are looking at m plus 8, m plus 4. 26, I'm just going to rewrite this as x squared minus 8x plus 7. This is going to factor. We're looking for what multiplies to 7 and adds to negative 8, so minus 7 minus 1. 27 careful. Are there any common factors? Yes, there are. 2 goes into everything. So factor that out. 2 times what is negative 54? Well, that's going to be a minus 27. So let's look at what we have here in green. How does that factor? Well, once again, you don't have to use that tic-tac-toe here. You never have to use it. It's really not necessary when the number in front of your squared term is 1. But just in case you're trying to get more comfortable using that method, I'll write it down. A goes in the middle. That's 1 because it's 1n squared. C is negative 27. A times C is negative 27. The factors of negative 27 that add to 6 are 9 and negative 3. So we have a negative 3, a 1, a 1, and a 9. You're going to check your signs, multiply through, and you say that, yes, 1 times 1 is 1. 1 times negative 3 is negative 3. 9 times 1 is 9. And 9 times negative 3 is negative 27. So you have correctly factored it. And remember, you're not solving, you're just factoring. And factoring is a useful tool when you solve later. So x minus 3, or I should say n minus 3, and n plus 9. Alright, almost done. 6 more problems. 28, 29, 30, 31, 32. Okay. 28, 29, 30, 31. So 28, solve each equation. Use the method of your choice. Hey, we've got a quadratic. You should identify that. You have your ax squared plus bx plus c. First thing I'm always going to try to do is factor. And I'm saying anything that multiplies to negative 4 and adds to negative 8. And the answer is no. We're going to have to go ahead and use the quadratic formula. So we have it set equal to 0. That's necessary. So the opposite of b, plus or minus the square root of b squared. Doesn't matter that it's negative because when we square it, it'll be positive. Minus 4 times a times c. Careful, you're going to subtract a negative. And that's all divided by 2a. So 8 plus or minus the square root of 64 minus negative 16 all over 2 is 8 plus or minus the square root of 80 divided by 2. And check, can you reduce the square root of 80? Largest perfect square that goes into 80 is what? 16? 16 times 5 is going to be 80. So if the square root of 80, oops, so think square root of 80 is equal to square root 16 times square root 5. Well, that's equal to 4 square root 5. So let's rewrite this as 8 plus or minus 4 radical 5 divided by 2. What can you factor anything out of the numerator? Well, yes, you can. If I look at the 8 and the 4, 4 goes into both of those. So 4 times 2 plus square root 5 all divided by 2. You can reduce 4 divided by 2. So think about the 4 in the numerator as 2 times 2. So when you cancel one of those out with the 2 on the bottom, you're left with 2 times 2 plus or minus the square root of 5. And it looks like I dropped my plus or minus in here. So there you go. There's the answer to 28. 29, which lives here. You say, hey, that's quadratic. That looks a little different. What do you notice on both sides? What's common? Well, you have a y on both sides, so one neat trick would be to divide both sides by y and see what happens. Or you say, well, it's a quadratic. I'm more comfortable setting it equal to 0. Y squared. So plus 7y on both sides. Now factor out a y, and you get y plus 7 equals 0. Okay, now what if I think about these as two separate quantities, y and y plus 7? When I multiply yellow times green, I need to get 0. So what makes the thing in yellow 0? Well, to make the thing in yellow 0, y would have to be equal to 0. To make what I have in green 0, y would have to equal negative 7. So those are my two solutions. So my two solutions are going to sit right here. And if you plug those back in, you would verify that they both work. Okay, number 30. 31. Okay, left-hand side I'm going to expand out. It's nice, you see that the left-hand side is factored, but look at the right, it's not 0. So it's not going to do you any good. So you need to expand the left-hand side and then move the 6 over. So first, outside, inside, last. I end up with x squared minus x minus 2x plus 2. I'll go two steps at once here. I'm going to combine like terms on the left, that's my x's, and minus the 6. So the right hand side is 0. 2 minus 6 is going to be my minus 4. Combine a minus x and a minus 2x to get minus 3x. So x squared minus 3x minus 4 equals 0. Does that factor? Let's see, does anything multiply to negative 4 and add to negative 3? That would be x minus 4 and x plus 1. So your solutions are x equals 4 or x equals negative 1. 31. Okay, go ahead and pull everything to one side. So you'll end up with 3x to the 5th minus 27x cubed equals 0. Now this is a little weird. You have it equal to 0. Now try factoring. What's common? Well, 3 shows up in both terms, and there's also an x cubed in both terms. So watch this. 3x cubed. We'll factor that out. So 3x cubed times what is 3x to the 5th? Well, that's going to be x squared. 3x cubed times what is 27x cubed? Well, that will be a 9. So if you think about distributing the 3x cubed back through here and here, would you end up with what you have here? The answer is yes. So, kind of weird. This is in factored form. Let me take out a couple of those lines. So it was x squared minus 9. Well, two things multiplied together to give you 0. Okay, I can handle this. So yellow times green equals 0. Real simple question. What does x have to be in order for this to be 0? Well, x would have to be 0. What does x have to be in order for this to be 0? Well, what's something squared minus 9 is 0. Well, the x squared has to be 9. So what would x be in order for x squared to be 9? X equals 3 or x equals negative 3. That graph has 3 solutions. If you looked at the graph, it would cross the x-axis 3 different times. So kind of a neat one there. Okay, 2 more problems. 32, 33. All right, 32. we're going to go ahead and we're going to expand everything out and try to gather some like terms and make it look like something we can work with. Y plus 3 squared will be y squared plus 6y plus 9. And you're going to subtract the quantity that you have here in blue. So you have to subtract y and subtract plus 3. So think about it almost as like distributing this subtraction to the y and to the plus 3. So minus y minus 3 minus 12 equals 0. Gather like terms to get y squared plus 5y 9 minus 3 is 6 minus 12 is negative 6. Does this factor? I hope so. It'll save me some work here so I don't have to do the quadratic formula. Alright, multiply to negative 6, add to 5, so that's y plus 6, y minus 1. The solutions are y equals negative 6 or y equals 1. Alright, 33. Once again, you're going to expand it out because like when you look at this you say, okay, something minus something equals 25. Well, how many things can you think of when you subtract them do you get 25? Really an infinite number of things. So there's no sense in guess and checking here. Let's expand it out. We're going to get a quadratic. So let's try to end up with a quadratic, and let's have it set equal to 0. Alright, 3x minus 1 times 3x minus 1. The middle terms will drop out. That will give you 9x squared plus 1. And you are going to subtract whatever 2x minus 1 times 2x plus 1 is. So that's 4x squared minus 1. And that's all equal to 25. Now, here's the critical point. You're going to subtract this quantity here. So I put it in parentheses for a reason, because I know that subtraction comes before. So I have to distribute this subtraction. So that's going to change some signs here. So I am going to rewrite this. 9x squared plus 1. Subtract 4x squared. And you're subtracting negative 1. So that's like adding 1. Okay, how many x squareds on the left? I got 5 of them. 5x squared plus 2 equals 25. Ooh, I made a mistake. If you notice right here in yellow, I think I went a little, well, that's not yellow. Right here in yellow, that should be a minus 1. Because minus 1 times positive 1 is minus 1. So let's fix it. So that's minus 1. That's minus 1. So the minus 1 and the plus 1 will cancel. So the left-hand side is 5x squared, and the right-hand side is 25. Divide both sides by 5. You have x squared equals 5. So x equals plus or minus the square root of 5. Whew, and we're done. Good job. I hope that this helps. I know I went fast, but good luck on your final, and have a good rest of the day.